I'm Frank Couturi, ecologist for the Grand Traverse Band Natural Resources. And with me today is Mike Burke, or Michael Burke, from Fluve. And Mike is part of the team. And the component that Fluve fills is the river restoration part. So really, these are the folks that came out and tried to understand where the river was in this valley, and then how to get the river put back in that same location. So I'll just let you talk to Mike.
Perfect. Well, thanks for joining us today, Mike. So how did you become involved in this amazing project?
Actually, some colleagues at Fluve became involved with Frank and the rest of the local stakeholders here as they had generated the motivation for the project, and we're looking for some help to understand the geomorphology and river ecology and hydrology and hydraulic engineering of the undertaking that they were looking at in removing the dams and trying to establish as best they could a river condition that emulated sort of the historical or pre-disturbance condition of the Boardman River here in the valley. So we've been involved with Frank and his partners over the course of several years now, doing relatively extensive field investigations and then helping on the ground through the implementation of these great projects.
So is a lot of your work based from an office, or are you generally out in the field? What's kind of...
Yeah, good question. We are very field-oriented or field-based in our approach to river restoration, understanding some of the fundamental physical characteristics and ecological characteristics of the river are just extraordinarily key components of restoration design. So we spend extensive time in the field in the initial assessment phases to know the river and the valley as well as we can. And on this project, there was relatively extensive historical research, clues and evidence that may have given some indication of what the river was like historically, and then we take everything back and work through detailed engineering designs, and then ultimately get back to extensive time in the field during the implementation of the projects, helping to interpret clues that are unearthed or exhumed when the impoundments are drawn down and digging through the sediment, finding indicators of what the river was historically before the dams were built.
No, absolutely. So for people that don't really understand, what would you say is the benefit to removing these 3 dams and also modifying the 4th dam here?
Well, really profound ecological benefits. Obviously, one that is key to all of this is not necessarily an ecological benefit, but managing some of the hazard or the safety risk associated with these very old dams. And as they near the end of their, they've reached the end of their useful life several years ago, and now they're just on the landscape here. And so a key component of the project was helping them manage some of the safety hazard with them. And then you move into the ecological benefits, just turning these relatively low water quality impoundments into riverine environments with just a tremendous continuity of species and all of the components that make up river ecology, from nutrients and continuity for all sorts of critters and things, as well as just establishing a continuous corridor, natural corridor from the headwaters all the way down into Traverse City.
Absolutely, it's going to be amazing once it's finished. So why are you actually at this particular site today? What's the reason for being here today?
Oh yeah, a real notable day today. So the project has been underway for about 2.5 months, and we have just finished up a phase where this extensive siphon system over here has been used to draw the pond down in a very controlled manner. And then today we shifted over from this siphon system to a temporary bypass channel or spillway system over here And this is really the first day that we've had the Boardman River running through the heart of the former dam. When we started the project, the height of the dam was from up where you see the light tower over here, crossed over to the top of the hill slope up there. So in the initial stages, the top 15 or 20 feet of the dam were taken down to where you see in the heart of the dam there was a concrete core wall. And you can see the evidence of that with these sticks of rebar sticking up in the air. And then over here you see some sheet piling. So the earthen embankment was brought down, and then a deep cut was made through that core wall to enable the river on a temporary basis to finally flow through the heart of the former dam. And so it'll be in this operation for a few weeks. And while we are running the river flow through this temporary structure, the real heart of the rest of the dam removal will then commence. The siphon system will be dismantled, and then the rest of the earthen embankment will be brought down. The rest of the core wall will be taken out, and then when all that work is done, the water will be put back in what will eventually be the future course of the Boardman River, but also the historical course of the Boardman River, and will be continuous with this section of the Boardman that was put back in its historical course over the course of the last few months.
Absolutely. So where we're stood right now, if people kind of look, we're kind of in the middle of as what people would look at as a building site. So what's going to happen with this piece here? What's this going to become for people?
Yeah, so this eventually will be just a continuous landform. The concrete will be, when this bypass channel is no longer being used, and the river is in its historical course here behind us, this temporary channel will be removed, and so there will be an earthen landform that will gradually descend down to where the course of the Boardman River will be here behind us. This big pile of dirt and the siphon system with the pipes and things will all be removed. So we'll just see a gradually descending landform down into the river channel and then back up to the side of the valley. So this is quite a detailed or elaborate siphon system that was used to bypass the entirety of the river flow for a period of about a month in order to draw down the pond in the impoundment just behind us to get it down to a level to start draining it and exposing the sediments and things further up in the impoundment. And while this work is ongoing, from the other end of the project, we've been working on the channel restoration, working on downstream. So today was the last day the siphons were used, and we've shifted the flow of the river here over to the auxiliary system. And while the river is over in that system, the rest of this will now be disassembled, and the future course and the historical course of the river will then be restored on through this area beneath where the siphon system is right now.
So the people of Traverse City will be able to enjoy the whole of the river and be able to use it recreationally as well as ecological benefits.
Absolutely.
So let's go have a look and see what the guys are doing down here. And can you talk a little bit more about this system?
The fundamentals behind the siphon system is just like as if you were siphoning gas out of a gas tank or something like that. Water will run from, even if there's a hump in the middle, the water will run from an elevation of higher elevation to lower elevation. So the whole idea with the siphon system is some pumps are used to start to pull the water up and over the hill, and once the water is running up and over the hill and back down to a lower elevation, it will just self-run because of the difference in water levels.
Absolutely. So then when it runs through, it comes to the end here.
Yeah, so as the siphons were operating, they would go through, and the water would go through and bubble out of these standpipes here, and then run on over the rocks and on into the river. The siphon system have been shut off, and now we're just We've been finding some very nice brown trout.
These are some of the Department of Natural Resources from the Grand Traverse Band of Dyer and Chippewa Indians, along with the Army Corps of Engineers, I think I see down there.
The design team and the construction team.
So if you ever wanted to see what 6 grown men chasing a brown trout looks like, this is it.
It tuned into the proper program.
The fish heroes.
Smallest fish we got was about a 14-inch brown. Everything has been over 20 inches.
We got kind of a smaller brown in there.
This is the fish they're rescuing. I'll let
Can you open that up for just a second? Yeah. Beautiful fish.
Yeah, there's 2 in there.
Not enough. All right, you guys got it?
You can go watch them when I get released here.
Yeah. Look at these beauties.
That is the treasure of this fish.
Just look at these absolute beauty fish that are being rescued here.
Probably the 50th, somewhere between 45 and 50 fish that we moved out of.
So do you want to talk a little bit about the ecology of a river?
Really, the way the rivers are formed, it's based on the geology of the area that they're in and the climate. So the climate and the geology, they drive those climatic conditions, and they also drive the way that the water moves across the landscape. And because of that climate, that influences how much water moves across the landscape. The geology has contributing factors on how that water moves across the landscape. So you think about rivers in different parts of the world, and you think about the ones that we have here post-glaciation. So we have these rivers that are based in a geologic climate that had basically glacial till and a lot of sandy, gravelly soils. And we also had a climate that produces, where we live here, 30 to 36 to 40 inches of rain a year. And then you take that rain, that hydrograph, the amount of water that hits the surface, that hits the ground in this area. And once it actually hits the ground, it's got to go somewhere. And depending on how the terrain moves and what the terrain is composed of, sands, clays, bedrock, that kind of dictates how the water moves across the landscape. Once the water moves a lot across the landscape, and it actually winds up into some sort of channel, then you start talking about the hydraulics, what that river does with the water and the sediments inside the channel. So you kind of build this in a pyramid, if you will. There's at the bottom you would have climate and geology. Above that you'd have hydrology, the amount of water that's in place. Above the hydrology is how it moves in the channel, the hydraulics of a river. Above that hydraulics, once you actually get how the water moves through a river system, you start talking about geomorphology, and that's how a river changes across the landscape and the tools it uses to change itself, like the amount of slope that's in that landscape, amount of slope that's on that water in the river, and the velocity or the amount of water that's actually in it. So the two factors are really slope, the amount of water, slope, the velocity. And so you build that, again, that pyramid. This is based on the stream function pyramid by a guy named Will Harmon, stream mechanics. You look at that geology and climate, then you look at the hydrograph for hydrology, then you think about hydraulics, how the water moves once it gets in the system, and then what the water does to the river once it's in the system. That's a geomorphology component. And then if you think after that water has changed the river, what happens next? It's really that the physical characteristics of the water, its temperature, its dissolved oxygen, its capacity. So, and then above that, really, then you can kind of think of everything that lives in it, the biology, all the critters that live in and around it.
So then, touching on this project and how that plays into that, with regards to the temperature of the river, what was the effect of having 4 dams on this river to the river and the river's hydrology?
Yeah, dams are sometimes mistakenly thought of as green power. Green power, definition of green power is something that's derived without any sort of pollutant conditions or detrimental effects on the environment. Dams are not green power. They're renewable energy, but they are thermal pollutants. They raise the temperature of the water, change the actual physical characteristics of the habitat that organisms live in. And not only do they raise the temperature, but they also segment the river system. So the creatures that need flowing water no longer have the ability to move through a system. They segment, raise the temperature, and then also there are many other things that the dams contribute to the ecological dysfunction of a river is they typically starve a river of sediment, and all sediment is certainly not bad. It's a necessary component of the way a river actually forms itself. But what dams do is basically stockpile all the sediment on the upstream side of the dam impoundment. So you don't have the sediment that moves through stream. You have clear water discharge that is warmer than it should be, and you don't have all the organisms that would typically live in and around a naturally free-flowing system, because the dam's going to break up, segment that system.
So in a nutshell, what this whole project is doing is taking what Mother Nature originally had and putting it back to the way Mother Nature intended it to be.
Sure, we have an elder at Grand Traverse Band. His name is Hank Bailey, and he likens this to blocked arteries, or someone who has to actually have a stent put in or a blockage removed. And he likens the river and the river systems as the arteries of Mother Earth. And to have those arteries flowing freely is what contributes to good health. And that's exactly what contributes to the health of our water systems, our watershed. The bay that everyone loves so much is a truly fully functioning riverine system. It's really ecologically important. You think of all the connections in the river. It's not just the water. It's not just the fish or the macroinvertebrates. It's all those related micro ecosystems that basically work in coexistence with that riverine system.
Absolutely. Well, thank you so much, Frank, for all the work that you're doing with the Grand Traverse Band that are putting this effort into putting this project together and working with all these partners to do their role as the caretakers of Mother Earth and protectors of Mother Earth. So thanks very much for joining us, Frank, and we'll follow this story some more, I'm sure.
Thanks for coming out, Kevin.
Thank you.